Okay, now you want to just give us name for NPCIL and thermodynamics subject, है ना?
Yes, sir.
Okay. So first of all, what is the difference between the open system and closed system?
Sir, open system are those systems in which energy transfer and mass transfer both are takes place. But in case of closed system, there is only energy transfer takes place, not the mass transfer.
Okay, just take an example of a pressure cooker used in a household applications. So, what type of system is this?
So basically, pressure cooker is both act as an open system and closed system. And there is the initial stage, or we can say unsteady state, when pressure is developed inside the pressure cooker. At that time, it acts as a closed system. When it reaches steady states and the pressure is developed and it goes to outside the pressure cooker, then it acts as an open system.
What are the different components of a Rankine cycle?
In Rankine cycle, mainly four different component is used. One of the is a pump, then boiler, then turbine, and then the condenser.
Okay, if I am considering each single one, just like a boiler, compressor, condenser, a pump. So, what type system is this?
Sir, these are the open steady flow system.
If I am just considering whole of the cycle, then
Yes, sir.
if I am considering whole of the Rankine cycle, then what type of system is this?
Sir, so it is a closed cycle, but the components are open systems, sir.
Okay, what is the difference between the PMM1 and PMM2?
Sir, PMM1 is a hypothetical machine which violates first law of thermodynamics, which say there is a device which creates its own energy without taking heat or energy from any source. And PMM2 says that there is a machine which takes energy from single thermal reservoir and convert that complete heat into work. PMM2 actually violates only second law, but PMM2 violates only second law. It does not violate first law, but PMM1 is violate first law.
Okay, what do you mean by zeroth law of thermodynamics?
So, zeroth law of thermodynamics says that if there is a three body and first and second body is in thermal equilibrium, second and third body is thermal equilibrium, then first and third body are also in thermal equilibrium.
What is the need of this law?
So, its law need mainly to make the thermometer, I think, sir.
So, can you just give me an example of three bodies in the case of thermometer?
Yes, sir. So normally we make thermometer in any industry from where it is calibrated. So the industry where thermometer actually made or calibrated with terms as body A, and thermometer I give the body name as C. Now it is normally used for the measure human temperature body, human body temperature. So human body is B. So basically thermometer made is industry. So it is must be in thermal equilibrium with industry. And when we measure temperature by the thermometer of human body, then it is also in thermal equilibrium. Then the reading I get in thermometer, the same reading I get in the industry if I go and measure them. So I can say it are also in thermal equilibrium. That are the three body in that case.
So, what is the law? Actually, just repeat it again. The law.
Yes, sir. Pardon, sir, I can't hear.
Please repeat the zeroth law of thermodynamics again.
Sir, zeroth law says if there is a three body, and then first and second body are in thermal equilibrium, second and third body are in thermal equilibrium, then first and third body are also in thermal equilibrium.
So, can you just tell me when you say that body A and B are also in thermal equilibrium? So, for a thermal equilibrium, is it required for any physical contact or not?
Yes, sir. Physical contact, I think needs, sir.
And body B and C are also require physical contact.
Yes, sir. A and B is physical contact, B and C in physical contact. Then A and C are also thermal
So
equilibrium
when you
automatically.
just explain the three bodies in the case of a thermometer, you take one body as a industrial, and
Hmm.
so
Yes, sir.
industrial is in thermal contact, is in physical contact with the thermometer.
Yes, sir. Because
Industrial, where you
yes,
just
sir.
measure the temperature, is in contact with the thermometer. Now, when you just
No,
go to
sir.
measure the,
No, sir. But the thermometer which I use for measure temperature, that is calibrated in the industry.
so what is the meaning of this? If you just
Means
considering the
the
calibration as a one body, so then how can you satisfy the other body when there is no physical contact? Either you take the some physical contact, either you present in the same environment.
yes, sir.
But in the case of industries lie somewhere in else, let us assume the thermometer is there in the Delhi, and I am going to measure the temperature here in Chandigarh. So can we just take as a both of them at the same environment?
No, sir. Environment is different.
Different, na? So how can you just take
Yes,
as a body A? What my question?
yes, sir. Got it.
Just define the entropy. What do you mean by
So entropy is basically says that, or I can say entropy is basically unavailable of energy, which basically indicate degree of disorder. Uh, with the increase or heat, or I can say energy, entropy is degradation, or can degradation of system is increases. So entropy is increases, and if we increase the temperature, then entropy degradation is decreases with the temperature.
what is the entropy of a source and sink? It can be increasing, decreasing, or constant.
Sir, in case of source, the entropy is we can take as a negative minus Q by T, the temperature of sink and the heat we extract. And in case of sink, we take is positive because temperature had supplied, where is Q by T, T is temperature and Q is the heat is which I extract from the source.
One statement you have just studied about it. A reversible adiabatic is an isentropic process, whereas
Yes,
all
sir.
isentropic process is not a reversible adiabatic. What do you understand by
Yes, sir.
this statement?
Yes, sir. This statement is correct. So reversible, sir, I write a equation. I use, sir.
Yeah, yeah,
So, according to, if we consider this statement as second law for processes, then reversible adiabatic means, so reversible means entropy generation is zero, and adiabatic means no heat transfer. It is also zero. For entropy is zero for reversible adiabatic. If I say isentropic, then for isentropic is entropy is zero, but we can another way entropy may be zero. If some heat rejection takes place, in that case entropy is negative and the process is irreversible, then some entropy is generated. Then overall it can be utilized as a zero, or we can say it can be zero as a. So in that case, it does not follow reversible adiabatic.
okay. What are the different types of path function in thermodynamics? कौन सी चीजें जो मेरी path function?
So in thermodynamics, mainly heat and work are path functions.
Only heat and work.
Yes, I know what to do.
What do you mean by entropy? Entropy is a path function or point function?
So entropy is the property, but entropy generation is path function.
So there are three terms na, which
Yes,
are
sir.
path functions. One is the heat, work,
Yes,
and entropy generation.
and yes, sir.
What do you mean by exergy?
So exergy is the maximum work we actually get when the system reaches to dead state.
Okay. What do you mean by irreversibility?
So irreversibility actually the difference between the maximum possible work before the system reaches to dead state and the actual work we get when the system reaches dead state. That's the difference is irreversibility.
Okay, Rakesh, just I will give the feedback. Overall, you are a good. You have a good knowledge about thermodynamics. Little bit you have just confusing in a zeroth law. Other things are all other. So just read it the zeroth law of thermodynamics. And
So
but
what
you are
three body I can
practical.
consider for a good example?
What?
For zeroth law, what should be three body can I consider for a good example that interviewer
It is an
can
example of
easily?
thermometer. Na? You can just take the example of thermometer, but you just define the body as a wrong. Na? One body is my, let us assume I am just measuring my temperature. The first body is me. Second body is the thermometer glass tube, and the third body is the mercury which is present in there. These are the three bodies, not the
Both are
industrial.
physical
Okay.
contact.
So body A is in thermal equilibrium with B, B is in C, and then A and C are also in thermal equilibrium. Okay. No issue. All the best. Just prepare the other subjects also. Huh?
Okay, sir.
Thank you so much.
Thank you, sir.